So when we talk about types of analysis, so decision on type of analysis basically depends on the selection of your variables. Your variable decide whether you have to go for univariate analysis or bivariate or multivariate analysis. If your dependent and independent variables are in metric and non-metric, so that will decide the uh, the type of analysis. If it is one variable in your study, so definitely it is univariate analysis. So one variable does not mean that you have only one variable. I mean, altogether, if you're having one objective to study, say for example, if you have one study to study to analyze the effectiveness of one scheme or one program or one project of government of India, say for example, right? So in that case, what you have to go for, you have to go for a very simple description from the audience side, right? Either you will take the survey on very nominal parameters or ordinal parameters, or even if it is the scales which are metric in nature, right? You will have specific variables. I mean, you're not relating one variable with another variable. You will only understand only one variable at a time. You're not relating two variables, and you're not identifying some kind of relationship or some kind of association between two variables. So such studies are basically known as univariate studies. And the only result you will get it, the description of particular phenomena or trend or per se the events, right? So here again, if your variables are metric in nature, you are having only three options. One is you can go for the mean, that means the average, or you can go for the standard deviation, right? How much they are deviating from the standard, from the mean or average. Or max to max, you can check the claims from the one sample t-test, right? So one sample t-test means, suppose you have to deal with one manufacturing operations or production operations, and you have to identify one defect from a particular lot size, right? I mean, 1000 products are being produced in one production cycle, and you have to check the claim that in 1000 production units, your manufacturing plant is giving only three products with the defect. So in that case, you can check that claim of having three defects out of 100 or 1000 samples through the one sample t-test, because here again one variable is under the study. You are not associating, you are not relating one variable of defect with any other variable, right? In that case, you can use univariate analysis. In case of non-metric parameters, a very simple use is count, I mean frequency and the percentage. So this is the analytical rigor that you can connect with the univariate analysis. Now the second thing is bivariate analysis, most important for secondary studies basically, right? So wherever we will use the secondary data related studies, specifically to the finance and economics or operations guys, where they want to understand some association or some kind of relation, some kind of impact of one variable or on another variable, or effect of one variable on another variable. Here there is a relationship between dependent and independent variable, right? If there are two variables and one is dependent and one is independent variable, so such kind of relationship can be examined through bivariate analysis. And the very basic I mean the analytical tool for that method is regression analysis. And when to use regression analysis? Specifically when all the variables, I mean both the variables, because it is bivariate, so dependent and independent, both the variables, if are in metric in nature, right? I mean metric means either they are in continuous scale or they are in ratio scale. Then we have to use the regression analysis. And you will see almost all the advanced analytics which is being used today in case of identifying relationship between two metric variables, or beyond that for prediction of something, right? Forecasting of the particular variables in the future timeline. So we always use regression or The advanced version of regression, maybe you can specifically for the time series analysis, you may have heard about the ARIMA model or SARIMA model, ARDL model, or NARDL model. Even if it is a non-linear relationship, here I'm talking about linear relationship, where I'm talking about the general linear equation, or multivariate linear regression, or this ARIMA, SARIMA, ARDL, and ARDL models, or number of other models which are linear in nature. But there are certain techniques nowadays which are non-linear also. Say, for example, extreme gradient boosting technique, or dynamic threshold panel analysis. So these are certain analysis which are basically having non-linear relationship. So they are identifying non-linear regression. So these are utilizing non-linear regression. But ultimately, you will find if there is a metric data, either in case of dependent on variable, the independent variables, the only the solution analytical tool is regression, or the advanced version of regression, maybe linear regression or non-linear regression, right? So now moving further into a kind of description of the bivariate analysis, when one variable is metric and another variable is non-metric, because you may also have such scenarios where one variable is in the metric form, specifically the dependent variable, and if independent variable is in non-metric form, right? So in that case, you need not to go for regression, because for regression you are having one restriction that all the variables should have a metric data. But what if you have non-metric data? How can you manage that? With the hypothesis testing, right? So in hypothesis testing, again, there is a very common test, t-test, uh, independent t-test, pair t-test. There are two different t-tests that has to be used, where there is a dependent variable as a metric variable and independent variable as a non-metric variable. Are you connected, class?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Right? So in such kind of scenario where there are two variables in picture and one variable is metric and another variable non-metric, then you have to go for hypothesis testing, right? And in that hypothesis testing, I'm talking about t-test specifically, independent t-test, dependent t-test, and the pair t-test, right? Now moving further, there may be chances that your all variables, be it a dependent or independent variable, if both are non-metric in nature, right? So non-metric means, again, either in the nominal scale or in the ordinal scale. So then again, you can go for a cross tabulation as a analytical tool. I mean, chi-square test is most appropriate in that case. So where to use t-test, where to use chi-square test, where to use regression in case of bivariate analysis is depending on the type of your variables, right? So you are not free to choose your analytical tools. So analytical tools are to be chosen on the basis of nature of your variables. I hope you are having clarity on this.
Sir, can we have the examples of all the three hypothesis testing, chi-square test, and regression, basis on all metric scale and
Mhm.
non-metric, and both non-metric one?
Yeah. Okay. Let's take an example. Take an example of the very common regression where there are certain climate-related variables, right? Climate-related variables means variables of temperature, humidity, rainfall, right? Suppose there are three different variables we have captured from some secondary database, right? So these variables are purely metric in nature, right? Because these are continuous variables.
Yes, sir.
Now the second thing, we are testing the impact of climate change on agricultural production, say for example, right? And we have certain parameters, certain variables for agricultural production in the country. Uh, Say for example, we are considering the Indian case, right? So agriculture, how can we capture the agricultural production in terms of metric variables? Maybe in terms of agriculture gross value added, right? Maybe in terms of a production of fruits and vegetables, maybe in terms of production of cereals and pulses in the last 30 years, right? So now in that case, you will see that both the variables. And now what is the dependent variable here? We wanted to check agricultural production or the agricultural growth, right, is somehow connected with the climate change, right? So what is the independent variable? climate change. What is the dependent variable? Agricultural production, right? So both are metric because we have captured the data from the secondary source, and both are into the continuous scale, right? So in such kind of relationship, if we want to identify the relationship, then we have to go for regression, or either OLS regression, or some kind of advanced version of regression, say for example ARIMA model, SARIMA model, or if it is non-linear regression, we can also go for some kind of non-linear models, right? So that is one example which is connected with the bivariate analysis. Now moving to the second one, where one variable is in metric in nature, another variable which is independent variable is non-metric in nature. Say for example, if you want to test the same thing, agriculture production as a dependent variable, where there is a gross value added captured by Indian government, right? Or cereal production, or the fruit and vegetable production in last 20 years, right? So that is what dependent variable, which is metric in nature. Now the second variable, if in the non-metric in nature, I mean independent variables, and we are having a claim that women attachment of women into the agriculture, right? I mean, how many women are attached with the agriculture in the last 20 years, or not women, man women ratio, say for example. I mean, every year if you wanted to check the how many male and how many female population were connected with this production, or maybe some other kind of non-metric variables, say for example what we can relate here, the age group, say for example, right? I mean the age group, farmers and the farmers age group, say for example. So or education for that matter, I mean how education of the farmers or the training conducted for the farmers, say for example, right? So how many farmers are connected with the training for agriculture production, how many farmers are not getting trained? So in such kind of scenario, we are creating non-metric kind of data where there is no continuous scale, there is a nominal scale, right? So in that case, if you want to test one group's relation with the another group, so what we will do, hypothesis testing, where there is a role of t-test, and t-test is being performed for measuring before and after, or even if it is the same sample, uh, before training and after training, right? Before particular education and after particular education, or for one group where there is a training and education, or one where there is a male counterparts are working, and where there is and checking, measuring the same, the mean difference. Basically t-test is nothing but the difference from the mean, right? So mean difference from for one group and for another group, and we are checking is there any relationship between these two groups, right? So in that case, what we will go for, we will go for hypothesis testing. Merely t-test will suffice the requirement if there is a dependent variable in metric in nature and independent variable is non-metric in nature. Now the third example is if both the variables are in non-metric in nature. I mean the dependent variables is always having in the nominal scale or ordinal scale, and the independent variables is also having metric and non-metric scale. Say for example, again women and men's participation in training, right? Or their performance before training and after training, right? And performance in terms of nominal scale, I mean good, average, and worst, right? So if we go for such kind of testing, so that is the cross tabulation, where both the variables are non-metric in nature. So we can perform the chi-square, very basic test, goodness of fit. Is it clear now?
Yes, sir.
Okay, now most important is multivariate analysis, which is basically required in the thesis. It's always suggested and recommended to go for multivariate analysis, because nowadays there are tools are very advanced, and there are large number of the basic relationship has been already examined, right? So the people are, and the researchers and the scholars are trying to relate some other variables with the existing established skills. As I was telling you in one day, that in case of quantitative analysis, there are thousands of models, right? And thousands of models on the basis of, the because there are large number of variables are in picture in case of secondary data research or primary data research, which is connected with the quantitative analysis. However, this is one of the beauty of the qualitative research, that there are very little models, minimal models are there, because we are not into the development of models, rather than we are focusing on synthesizing the literature or synthesizing the empirical evidences based on the observations, right? So in case of quantitative analysis, although it is little bit easy in terms of analysis part, that you can perform analysis with the help of tools and what we can say, the application softwares very easily, but it is very difficult to create a very novel model, because already existing 1,000 models are there, right? So therefore there is a role of multivariate analysis, that you can read some models and try to modify some models with some kind of inclusion of your some dependent or independent variables, right? Again, in that case, the selection of multivariate analysis is again depending on the variables that you will select, right? Variable and the nature of the variable. Now look at this table. The first quadrant here, I have created, it's 3 by 1, 2, 3, 4, 5. 3 by 5 matrix, 3 by 5 matrix, right? So in this 3 by 5 matrix, if you look at my cursor, is it visible to you? My cursor is roaming here.
Yes, sir.
Are you able to see my moving cursor?
Yeah, it is visible.
Yes. This first quadrant, right? So where to use, I mean, these all different quadrants are here, not quadrants, basically. These are the, I mean, 3 by 5 matrix. So these different columns, right? Or these different tabs are basically telling you about different analytical techniques, right? So these selection of analytical techniques is depending on these variables nature, whether metric or non-metric, whether one variable or more than one variable, right? Similarly, if you see here, variable, metric and non-metric, one or greater than one, right? Now see, this will decide which is most appropriate technique which has to be used for your particular model. Because ultimately you have to create a model. And once you will create a model, after a rigorous literature review, you have to decide which analysis, which technique or which test you have to use. And for that matter, this table will give you support. I mean, this table is a perfect solution for handpicking the best analytical tool for your study. Now look at the first one here, first column, first tab, which is talking about regression. Now where to use regression, as I already mentioned, if both the variables are metric in nature, you have to use regression analysis. And now see, if dependent variable is 1 and independent variable is 1, both one variable, independent, and both are metric, you have to use regression, right? Now see, if dependent variables are more than 1, look at the third column, fourth column, last column here. Last column is talking about dependent. What if the dependent variable is greater than 1? If dependent variable is greater than 1 and independent variable is 1 or more than 1, in both cases, you have to use structural equation modeling or path analysis or multivariate analysis of variance. Is it clear? Where to use which analysis? Now look
Yes,
at the
sir.
second one, the third column here. If dependent variable is non-metric and 1, you have only single dependent variable, which is non-metric in nature, and your independent variable is metric in nature, just opposite. In that case, you have to use linear discriminant analysis, right? Now see, if there is a one dependent variable which is metric in nature and one independent variable which is non-metric in nature, then you have to go for ANOVA, but this has to be one-way ANOVA because there is one independent variable. Now see, if this one independent variable has been increased to many independent variable, look at this, the first row, right? And dependent variable is 1. The one-way ANOVA converted into n-way ANOVA, n stands for number of independent variable. If independent variable are 2, it has to be 2 ANOVA. If it is 3, it has to be 3 ANOVA, likewise, right? Now look at the cross tabulation. As I already told you, if dependent variable is non-metric and the independent variable is also non-metric, in that case you have to use cross tabulation where there is a chi-square test. Right? Now there is a difference between test and techniques. What are the tests? Where there is where you are checking the difference between two groups, right? Where you are having a check to test two different groups. That is basically known as test. So in that case, if it is a hypothesis testing with t-test, whether independent, dependent, or pair t-test, you will find that t-test is a test. However, if it is a regression or discriminant analysis or ANOVA or MANOVA or SEM, right, or different this multinomial regression, these are techniques, right? Now what is the test? Test is those experiments, those studies, those analysis where you have to perform the differences in two groups and you are trying to test whether there is a significant difference in one group's mean is equal to the difference of the mean of other group, right? That's a t-test. If it is regression or ANOVA or MANCOVA or ANCOVA, right, or some other test, multi-level discriminant, multiple discriminant analysis or multinomial regression, all these other the methods are basically techniques. So this is a difference between test and technique. Even chi-square is also a test, right? Chi-square is a test, t-test, independent sample t-test, dependent sample t-test, and pair t-test. These are the t-tests. Chi-square is also the test, and all other are techniques. Now, what about the tool? Tool are the facilitators which are facilitating you for conducting the analysis. So tools may be your applications. I mean, Excel is one tool that you can work on your independent variables and you can plot one regression analysis, right? SPSS is another tool. R platform is a tool. Python is a tool, right? So the difference between test, technique, and tool has to be very clear. Now moving to the last slide here. Now you will see if there are mixed independent variables, right? Mixed independent variable. Some metric, non-metric. This may also be a situation, right? So in that case, it's not ANOVA, it is ANCOVA. Now, what is the difference between ANOVA and ANCOVA? In case of ANOVA, it's analysis of variance. In case of ANCOVA, it's analysis of covariance, where we have to take one covariate into the ANOVA. ANOVA plus covariate. So covariate is one of the continuous variable which is equally impacting the dependent variable, right? So we are taking the covariate into the consideration when it comes to analysis of covariance. So little bit related word, ANOVA and ANCOVA. ANCOVA is the extended version of ANOVA, where covariate are also taken into the picture of the continuous, because the covariate has to be continuous in nature, but you will see, because it is a mix, you will find that metric and non-metric variables in the ANCOVA in case of independent variables, right? And definitely dependent variable has to be metric for that. Wherever you will use ANOVA and ANCOVA, you will find that dependent variable has to be metric in nature. If it is non-metric, then either you will go for multinomial regression where the logit and probit models are there, right? You have heard about logit and logistic regression, right? Where dependent variable may be non-metric. You wanted to test the impact of one thing on male and female, right? Gender, how gender is connected with particular event, right? In that case, if you have considered dependent variable, gender as a dependent variable because non-metric in nature, so in that case you will go for multinomial regression. So logistic regression is a type of multinomial regression, right? And if it is again cross step where there is large number of independent variables greater than n, so it's a complex cross step, nothing else. We are extending the cross step into the complex cross step where it is extended from 2 to 2 quadrant. I mean, 2 by 2 matrix is now converted into 3 by 2 or 4 by 2 matrix, right? And the most uh, especially for psychometrics and psychological studies and behavioral science studies, the structural equation modeling and path analysis, these are the trending tools. These are the trending tools. But again, I just wanted to convey here, uh, if you are going for experimental studies, the very normal, hypothesis testing, where there is a, I mean, this ANOVA or through ANOVA or through t-test, right? You can write wonderful papers where very little analysis, I mean, very common analytical tools, techniques you can use or test you can use, and you can perform, experiments, right? Although in case of experiment, uh, one experiment is not suffice the requirement, as the minimum number of participants in one experiment is 25. In some papers, it is written as 30 participant, right? And at least 2 to 3 experiment has to be, series of experiment has to be conducted for a good study. The results of first experiment has to be significantly connected with the second experiment, has to be significantly connected with the third experiment. So series of experiment are nowadays acceptable in terms of good research article or good thesis or good publication. Are you able to understand?
Yes, sir.
Now it's your I mean, I'm recommending, it's of course your duty, that you have to look at all the multivariate analysis and then how to perform the different analysis, right? And specifically for the economics or finance guy who wanted to just work on a kind of the data from the secondary side. So multiple regression is this multiple regression and multi-nominal regression. These are wonderful techniques that you can build upon. I mean, you can think and you can develop expertise on these tools. And one more thing, it's very difficult to get expertise on all the tests and all the techniques. Command over 2-3 techniques and 2-3 tests that will suffice the requirement of your area. Say, for example, if it is psychometrics or the behavioral science, you have to go for this SAM and path analysis, wonderful techniques. If it is secondary analysis, secondary database related studies, you have to get mastery over multiple regression and multi-nominal regression. That will suffice the requirement, right? But of course, add-on is always better. The add-on package, as much you can add, that will definitely provide you a substantial leverage with the competitors, right?
Sir, may
Okay,
I add
now,
one thing?
yes.
Till our post graduation or graduation, many of us have studied regression. Many of us have studied ANOVA, t-test,
Hmm.
chi-square test. Maybe some of us we have studied Mancova also, but we have not
Hmm.
studied all these SEAM, path analysis. Path analysis, I suppose it is PERT and CPM, if I'm not wrong.
No. In that case, it is not that path analysis. This is the direct and indirect path of the relationship in a particular model. Suppose I'm talking about one relationship where I say X variable is leading to Y variable, is leading to Z variable, and ultimately leads to A variable. Say, for example, right? Very simple relationship between 4 construct. X construct leading to Y construct leads to G construct leads to A construct, right? So suppose this is my relationship, or in between, suppose there is a mediation, right? So in that case, I'll check the path whether right from X to Y and X to Z directly X to A, right? What these
सर
different
दिस
path
दिस वी डू इन
significant.
पर्ट ओनली ना पर्ट में भी तो हम यही करते हैं पाथ ही ड्रॉ करते हैं ना क्रिटिकल
नहीं,
पाथ मेथड
पाथ
में
ड्रॉ करते हैं, बट यहाँ पर जो एनालिसिस होगा ना, दैट एनालिसिस इज नॉट दैट पाथ एनालिसिस. वहां पर तो हम दैट इज बेसिकली ऑपरेशंस के टेक्निक्स हैं. द पाथ एनालिसिस बेसिकली इज अ टेक्निक यूज्ड इन दी ऑपरेशंस, जो आप जिसकी आप बात करें, पार्ट एंड सीपीएम, राइट? वो ऑपरेशंस का पार्ट है, बट हियर इट इज अ पार्ट ऑफ रिसर्च. आई मीन स्पेसिफिकली टू अंडरस्टैंड द रिलेशनशिप बिटवीन 2 वेरिएबल्स और 2 कंस्ट्रक्ट. हम यहाँ पर रिलेशनशिप स्टडी करते हैं. सो I mean, we are talking about the path from one construct to another construct. I mean, how much it is signified with respect to the again the base of all the equation is correlation and regression.